In this session, we're going to look into another application of stack. There are three ways of writing an expression. For humans, we understand infix expressions better. Infix expressions are where the operator is in between the operands. Operands means the numbers, the values or variables we do the operation in, and the operation is denoted by the operator. So this is the most common version of expressions we have seen so far. These expressions can also be written in two other ways. One is called postfix, another is called prefix. In postfix, the operator comes after the operands, and in prefix, the operator comes before the operands. In this lecture, we will only be concerned with infix and postfix notations. This is because when we feed an equation to our computer, we usually give it in infix form. But however, for computers, they cannot evaluate infix notations. They can only evaluate postfix expressions. So what they do is they convert the infix expression to postfix and then evaluate the resulting expression. So in this lecture, we're going to learn how to convert an infix expression to a postfix expression. Now it's important to note that infix notations contain brackets. That is, when we write our equations, we usually give brackets to show the precedence. Also, when there are multiple operators, we need to know the operator precedence, that which operator should be executed first. However, in postfix notation, there are no brackets. We do not need any bracketing because the way the expression is written, the operator with the highest precedence will automatically be executed first. And it is easier for computers to compute also because here operator precedence does not need to be known. The expression itself is enough to decide which operator should be executed first. If I want to add the value of A with B, then this is how we write it in infix form, A plus B. The plus sign will appear between A and B. The same equation in postfix form will look like this, AB plus. This tells me that addition is being done between A and B. Now try to write the postfix form of this expression. This should be the answer. So over here, as I parse through this expression, I can see that there is a multiplication sign here. This means B and C will be multiplied. And then the answer of B into C will then be added with A. So as you can see, it might get a little bit confusing for us to write the postfix form even when the expression is relatively small. So in the next lecture, in the next slide, we're going to learn how to write a postfix notation form of an infix expression. The conversion from infix to postfix and vice versa can be done using a stack. So these are the rules that we will have to follow to do the conversion. I will explain the rules as we follow the steps one by one. Now we will convert this infix notation to its postfix form. So the thumb rule is whenever we see an operand, that is a number or a variable, then we will directly write it to our postfix equation. If we see an operator, that is plus, minus, division, multiplication, whatever it is, for any operator, it will be pushed inside the stack. And while pushing the operator, we need to keep the precedence in mind. So these are just the common operators that I've written. And by now, I hope all of you know the precedence. That is multiplication, division, and mod have the same precedence. and plus minus, they have less precedence than these operators. So I will start parsing this expression. So first I get A, this is an operand, so I will push it inside. So since it's an operand, I will not push it, I will write it in my postfix expression. So A has come over here. Next, I will come to the next character. Since it's an operator, I will push it in my stack. Now the rule is, when I push an operator in my stack, I need to make sure that this operator has the highest precedence than the rest of my content in the stack. So whether I should be able to push plus in my stack or not will only depend whether plus has the highest precedence than the rest of my content. So can I push plus here? Well, there is no other content in my stack, so I don't have to compare with anything. So plus will be pushed inside my stack. Next, I will move to B. It's an operand, so I will write it in my expression. Next, I will go to multiplication, and it's an operator. So I have to decide whether I can push this operator in my stack or not. So the operator is a multiplication sign. I can only push this multiplication sign if it has the highest precedence than the rest of the operators. So can I push multiplication? Yes, I can, because multiplication has a higher precedence than plus. So I will push multiplication sign inside my stack. And then I'll move on to C. It's an operand, so the operand will be written in my expression. And once I'm done parsing through my whole expression, I can see that my expression has finished. So now I need to pop the content of my stack. So I look at my stack and I see that I have operators remaining. So I will write these operators in my expression by popping them. So if I pop the stack, this will be popped first. So multiplication will come over here, and plus will come over here. I will keep on popping until my stack is empty. So now that my stack is empty and my expression has finished, this is the equivalent postfix notation of this infix expression. Now let's do the conversion for this expression. To begin with, I have A, which is an operand, so I will write it in my postfix expression. Next, I have multiplication. And since it's an operator, I will push it inside the stack. Now, before pushing it inside the stack, I have to check whether multiplication has a higher precedence than rest of the operator in my stack. Since there is no other operator in my stack, so I don't have any operator to compare multiplication with. So I will just straight away push the multiplication operator inside the stack. Next, I have the operand B, and it will go to my expression. Next, I have the plus operator, and an operator should be pushed inside the stack. Now, before I push it inside the stack, I have to check whether it has a higher precedence than the rest of the operators inside the stack. So does plus have a higher precedence than multiplication? No, it doesn't. So I cannot push the plus operator right now. So what we have to do is we have to pop the stack until I can push the plus sign in. So as long as multiplication is over here, I cannot push the plus operator because my rule says I can only push an operator if it has a higher precedence than the rest of the operators inside my stack. So I'll have to pop the stack. And when I pop the stack, this operator will go to the postfix expression. And after I have popped it, now I can push the plus operator. So this will go into my stack. Next, I will parse the expression. C is an operand, so it will go to the postfix expression. And then I see that I am done with the full expression. So now that I do have an operator left in the stack, I will keep on popping my stack until I have popped all of the operators. So plus will go over here. Since my stack is empty and my expression is finished, this is the equivalent postfix notation for this infix expression. Now pause the video and try to convert this infix notation to its postfix form on your own. Okay, so let's start. Since it's an operand, it will go to the expression. Then I have an operator plus, it will be pushed inside the stack. Then I have B, an operand, so it will go to the expression. Then I have multiplication. So can I push the multiplication inside the stack? Yes, I can, because multiplication has a higher precedence than plus. Next, I have C. This will go to the postfix expression. Now I have minus. Now, can I push the minus operator inside the stack? I can't, because this has a lower precedence than multiplication. So I will have to pop multiplication. I have to pop the stack, and the multiplication sign will go to the postfix expression. And now let's see. Now can I push the minus sign in? No, I still cannot push the minus operator inside the stack because it does not have a higher precedence than the rest of the operators, because minus and plus, they have the same precedence. Even if they are the same precedence, even then I cannot push the operator inside the stack. So it has to have a higher precedence. So plus will go over here. And then I can push the minus operator inside the stack. And then I've parsed my expression. I have reached D. So D will come over here. And now I will pop the stack. Because I'm done with my expression, so I will pop the stack and minus will come over here. So I'm done with the postfix expression of this infix notation. Next, we will learn how to convert an expression if it has brackets in it. So when we start, this is an operand, so it will go to the expression. Next, we have an operator. It will be pushed inside the stack. Next, I have B, an operand, so it will come to the expression. Then we have the multiplication operator. And can I push multiplication? Yes, I can, because it has a higher precedence than plus. Next, I see an opening bracket. So the rule is, whenever you see an opening bracket, you will simply push it inside the stack. You don't have to check for anything. So it has been pushed. Next, I have C, so it will go to the expression. And now I have the minus operator. So the question is, should I push the minus operator inside the stack or not? So you see, if the opening bracket was not present, then I could not have pushed it because I had the multiplication operator, and I couldn't push minus because minus has a lower precedence than multiplication. So I would have had to pop the multiplication sign and then also the plus sign, and then I would have had to push the minus sign in. But since I have an opening bracket here, try to assume this opening bracket as a shield, as though when the minus comes over here, it cannot see the elements that are before the first bracket. So the first bracket works like a shield. So I can push the minus in because this operator, this bracket, the opening bracket, sort of hides the previous contents of the stack from the operators that will come after it. So when I have minus here, I will push it inside. Okay, try to understand that if this opening bracket was not present, then I would have had to pop these operators and then push the minus in. And since the opening bracket is present, it sort of hides the previous operators. So I can push the minus sign in. Then I have D. D will come to the expression. And now I have the division sign. So when the division comes over here, it will only be compared with the minus, because again, this works like a shield. It cannot, this opening bracket hides these operators. So I just have to check that whether division has a higher precedence than minus. Well, yes, it has a higher precedence, so the division operator will be pushed inside the stack. Next, I will go to E. E will be written in the postfix expression. And then I have the closing bracket. So the rule is, when the closing bracket comes, I now have to pop the stack. Okay, so the closing bracket, whenever I encounter a closing bracket, I will have to pop all the contents of my stack till I receive an opening bracket. Okay, so the closing bracket tells me that I have to pop the stack now. So I will pop the division sign and it will go to the postfix expression. And then I will have to pop the minus sign and it will go to the expression. And next, when I pop, I receive the opening bracket, so I will stop the popping over here. Next, I will keep on parsing my equation, but since my equation has finished, I stop parsing and I see that my stack is not empty, so I have to keep on popping the stack until it becomes empty. So popping it will first remove the multiplication operator, so it will go to the expression, and then the plus will move over here. And this is the postfix equivalent expression for the infix notation. Now pause the video and try to convert this infix notation to its postfix form. Now usually when I'm given a big equation that contains a lot of operators and operands, I prefer writing my stack like this, drawing my stack like this. That way it's easier for me to simulate. So this will be considered as the top of my stack, and I will write the operators horizontally. So you can do whichever you want to. So pause the video and try to come up with the expression on your own. Okay, so in the beginning I get A, which is an operand, so it will come to the expression. Next I have the multiplication operator. I will push it inside the stack. Since there is nothing in my stack, I don't have to compare this operator with anyone, so it will just be pushed inside the stack. Next, I have the opening bracket, and whenever I have an opening bracket, I will push it inside the stack. Next, I have an operand, and it will go to the expression. Next, I have the plus sign, and you see, I can push the plus sign in because this works like a shield. It does not let me see any operator before it. So since I have an opening bracket here, the plus will not be compared with anyone. I can just simply push the plus operator inside the stack. Next I have C, which is an operand. It will come to my expression. And now I have minus. So before pushing minus in, I will have to check, does minus have a higher precedence than plus? Notice that I don't have to compare the minus with any of the operators before the opening bracket, okay? Because the opening bracket hides the operators before it from the next operators. So minus can only see the plus over here. So does minus have a higher precedence than plus? No, it doesn't. So I will have to pop the plus sign. So it will come to my expression, and then I can push the minus operator inside the stack. Next, I have another opening bracket. And the rule is, whenever I have an opening bracket, I will simply push it inside my stack. So this goes inside my stack. Next, I have D, which will come to the expression. Then I have plus over here. So can I push the plus in? Yes, I can, because I have an opening bracket here, and this opening bracket hides all of the contents that is before it. So I don't have to compare plus with anyone to check whether it has a higher precedence, because the plus cannot see any of the operators before it because it is covered by this opening bracket. Then I have E, it will come to the expression. Then I have the division sign. So can I push the division sign in? Yes, I can, because division will only be compared with the plus sign, and division has a higher precedence than plus. So it will go inside my stack. Next I have F, and this will come to the expression. Now I have a closing bracket. So what I usually do is I write the closing bracket inside my stack and I cut it out with my pen to show that all of this content should now be popped out. Okay, so when I have a closing bracket, that is a closing first bracket, that is all the contents between the closing first bracket and the opening first bracket should be popped out. So if I pop these elements out first, the division sign will be popped and it will come to the expression, and then the plus sign will be popped. And I will remove this from my stack. Now I will parse my expression, and I have a closing bracket here again. So what I usually do is I write it inside my stack and I cut it out with my pen to show that all the operators inside the stack will now get, all the operators within these brackets will now get popped. So since I got a second bracket, I will put the cross between the opening second bracket and the closing second bracket, and I will pop the contents to the expression. So if I pop this operator, I have only one, so minus will come over here. And then I will remove this. And I have completed parsing my full expression, and I see that my stack still has an operator in it, so I will pop the stack. And that's it. My stack is empty, my expression is completed. So this is the corresponding postfix expression for this infix notation. Notice one more thing, that when my infix expression has brackets, even then the postfix expression does not have brackets. So the postfix expression is much easier for computers to handle because they do not have any brackets to deal with.